Hello, calculus fans! So let's let R be the region bounded by y equals x squared plus 2 and y equals 4 minus x squared. We're going to take this region and revolve it about the line y equals negative 3 to obtain a solid. And we're going to find the volume of this solid. Alright, first things first, let's look at a picture. Alright, so we've dealt with regions like this when we were calculating areas. So there's our region. Down here, you see our axis of revolution. And then I've also marked an inner radius and an outer radius. You might think, how do I tell the difference between the inner radius and the outer radius? Well, the outer radius is the one that's farthest away from the axis of revolution. The inner radius is the one that's closest. So when you decide to slice it like this, then the boundary of that slice that's closest to the axis is the inner radius, and the one that's farthest is the outer radius. Alright, so the outer radius is 4 minus x squared plus 3. That's because there's an additional 3 units to get from the curve to the axis of revolution. This portion of it is a y distance that takes you from the curve down to the horizontal axis, and then you have to go an additional 3 units to get down to the axis of revolution. And in a similar way, the inner radius is x squared plus 2 plus 3. So this right here is the curve that defines the lower bounding portion of that region, and so that gives you the inner radius. All right, we can now write down the volume of a slice. Delta V, remember how this works, pi times big R squared minus little r squared times thickness. So we plug all these in, so big R is 7 minus x squared, little r is x squared plus 5. We put those in our formula for the delta V and we get this expression. Now we need limits of integration. We'll find that by getting our intersection points. So we'll set x squared plus 2 equal to 4 minus x squared. Remember, those were the curves that we started with. And we solve for x. We end up getting x equals plus or minus 1. Okay, we're ready for the volume. So the volume is integral from negative 1 to 1 pi times big R squared minus little r squared times dx. All right, so we just have to multiply things out. It's a little bit of algebra. It's not too bad. And we get something that looks like this. Pi times the integral from minus 1 to 1 of negative 24x squared plus 24 dx. I don't want to make a big deal out of this because this is actually a really easy integral to do. It's worth noting that we can just do half of it and then double our answer. If you go back to the picture, there's some symmetry about the y-axis, so it makes sense that we should be able to do something like this. And we anti-differentiate to get minus 8x cubed plus 24x. That's evaluated from 0 to 1. Plug all that in, and we get our final answer, which is going to be 32 pi. Okay, that's all for now.